In this lecture, we are going to introduce basic tools, and these tools are the tools that are used in every electrical maintenance and all the electrical stuff must have. So first of all, we are going to talk about screwdrivers, and screwdrivers are used to loosen or tighten screws with slotted heads. So the first screwdriver is the flathead screwdrivers, and this is a common screwdrivers. The blade type is wedge shaped and resembles a negative sign. So if you see a bolt with a negative sign, you need to use a flathead screwdrivers. The next is the Phillips head screwdrivers. This type of screwdrivers comes with angle trips to allow them to fit deeper into the screw head, and this will reduce the chances that the screwdriver will be sliding out of the bolt face. So this design allows you to apply greater torque to the driver because or the Phillips head screwdrivers will not go out or slide out of the bolt. And the next is Torx screwdrivers with a blade with a star-shaped tip, and this is to increase the contact area between the tip and the screw head, and this allows more application of the torque comparing to the Phillips head screwdrivers. In pieces or in machines where you need a lot of torque, you can apply this type of bolts with Torx faces. So the last commonly used screwdrivers is the hexagon, or sometimes this is called hex. So instead of a blade with a tip at its end, hex features a hexagon recess. So there is an open in the middle of this screwdriver, so this design facilitates their unique use in the fastening of bolts rather than screws. You can use these types of screwdrivers in electric motor terminals, in transformers, and like that. So the basics are Phillips screwdrivers and flathead screwdrivers, but if you carry these four items, you will not have problems in any maintenance. So here you can see the face of a flathead bolt when you see from the top, and this is the flathead screwdriver used to fastening this bolt, and this is the bolt. This is the Phillips, and you can see we have a plus signal with a curve. So this is the bolt from the top, this is the screwdriver, this is the bolt shape. So this is an evolution of the Phillips screwdriver because we have here some entrances. These entrances will create more contact surface between the screwdriver and the bolt, so you can apply more torque using this bolt and this screwdriver comparing to the Phillips. So here you have the torques, and you can see that we have a lot of area or surface to be in contact with the screwdriver. This will give you a lot torque comparing to the previous ones. Also, this is another type with a security because this is a screwdriver that is not common in maintenance. So if you place some bolt like this, that will be something like a security bolt, and you cannot use these torques because there is a surface area in the middle, so we'll be in contact with this one, so these torques will not work here. So you need the special torques, and this is why we call this security, because this is not common used in industries. So the next one is this hexagon, and this is also used in motor terminals and switch gears. So you can see the face of this bolt, and this gives you a lot of torque also. So the next basic tool is the pliers, and the plier is used for cutting, twisting, bending, holding and gripping wires and cables. And the first plier most used is the combination, and this is used for gripping, holding and cutting electrical wires. So there is a combination of these basic tools. So you can see the image of the plier. In the first section we have some area or something like a knife to cut electrical cables or wires, and in the middle you have some gripping area, and in the front you have an holding area to hold cables and bring cables to front or back, and sometimes arrange cables. And the second plier is the side cutting, and this type of plier is used for cutting fine, medium and big wire cables. So in the combination we seen this small surface for cutting, but with the side cutting plier the cutting is more precise, so this is only used for cutting. And the next is the long noise peeler, and this is used also for cutting and holding fine wires. Sometimes you will have a long noise peeler for cutting with the cutting surface, but this shown here has no cutting surface, so this is only applicable for holding wires. And also this type of plier can reach tighter spaces or small openings where another pliers will not be able to reach the cable or some other objects you want to catch. So here you have an example of how to use the most common types of pliers. So this is an image of all the pliers available in the market. So you can search to see the application of each one, and one of them are also used in electrical maintenance, but in specific cases. And the basics are the three shown here for you to be successful in every electrical maintenance. So another basic tool is the wire stripper, and it is used to strip the electrical insulation from electrical wires. So to remove the insulation from wires and leave the copper without insulation, we use the wire stripper. And this is one of the most common you will find in the market or industries. You have here, you can apply a cable or place a cable here, and if you apply a force here you will remove the insulator from a cable. Also you have these cut surfaces here, so this is not to cut the wire, but this is used to strip the insulation of the cable. So you don't have to apply a lot of force when you place the cable in this area. You apply a little force, and when you feel that the insulation is already cut, so you move vertical the striper, so the insulator will go out. And this is also another type of wire stripper. So you adjust the diameter of the conductor with this bolt, so you will not apply a lot of force to this surface where you will insert the conductor, because let's suppose you apply a conductor of 4 millimeters, but you adjust this bolt to a conductor of 1.5 millimeters of diameter, so this bolt will move internally, and you will allow more contact between this plate and this one because the limit is more inside. So when you place the cable and you bend these two areas or arms, you will cut the conductor instead of cutting only the insulation of this wire. So this is also a common stripper you will find in the market, and you also have this one with small cutting surfaces, and this is equal to this area of this stripper. So the only difference is that this stripper has now this part here, but here you have different diameter of cables, so you will not cut the cable if you apply a lot of force because the holes are already sized for specific cable insulations. So if you have a 6 millimeters you place in this hole, if you place here you will cut the cable. If you have 1.5 you place here. If you place here the 1.5 you will not cut even the insulation because this hole is for 2.5. Let's see how we apply this tool to stripper the wires. So you can see how this is easy to strip wires with this tool. You can strip multiple wires in this area. So another basic tool is the electrician's knife, and it's used to remove insulation of wire and cables in low and high voltage transmission lines, also in the medium voltage. So you can see all the type of knives. So the most common, or it's practical to use insulated knives because sometimes in the medium voltage you can have some residual voltage in the line, so this is better to use insulated knives instead of this one with wood. And here you can see the application of the knife. So this is a knife with a special part to remove the insulation. And you can also use this surface to cut the wire, even the copper or the conductor. And another basic tool is the ground stick, and it is used to divert current to the ground. So as I said before, sometimes in medium voltage you can have residual voltage even in high voltage. So this residual voltage can reach values like 1 kV or 2 kV. So if you touch this voltage you will get electrocuted. So to avoid this electrocution we use the ground stick. And also sometimes in motors you will find charged capacitors, so it's better to ground the terminals of the motor, so when you touch the current will not pass through your body but it will divert to the ground because you connected the ground stick to the circuit. So the first one is this type of ground stick, and this is used for medium voltage. You can see that you will be touching in this part in black. This is an insulation part, even the body. And why we need this distance between this part and this part, because we know that when in high voltage the residual voltage in the line can reach bigger values, so you cannot approach the line like we approach in the 220 volts because there is an electric field. And if you get in contact with this electric field and you don't respect the minimum distance, the air that is insulating this electric field will be disrupted and there will be charge passing through your body from the line to the ground. So you will get also electrocuted even if you're not touching the line. So let me explain better. So what I was saying is that if you have a wire and if you apply high voltage to this wire will create electric field around the wire. So this electric field depends in the voltage you apply. So if the voltage is a low voltage, you will not have this electric field so high in strength around the cable. You will have an electric field so small in area like this. But when the voltage is increasing, the electric field goes more powerful and increases its diameter alongside the wire. So if you approach this magnetic field and you reach a certain distance, that we call this a minimum distance, where the air will disrupt and will not be an insulation anymore. We call this the disruption of air, and this is given when the electric field is equal to or greater than 3 kV per millimeter. So if you find the electric field of 3 kV per millimeter, the air will not insulate anymore. So there will be a discharge from the conductor to you, and the current will flow. If you are in the ground, the current will flow to the ground and you will get electrocuted. So this will not happen if you're not touching the ground, but if you're touching the ground, you will get electrocuted. That's why birds can be sometimes in electric cables not insulated and don't get electrocuted because they are not in contact with ground. But also, if you are separated in a certain distance with ground and you are not in the ground, you are in some kind of air, but you disrupt this electric field and you find this value, you will get an arc to energize your body, but there will not be flow of electrons because you are not in ground. Let's suppose the ground was here. You will not get in electrocuted, but you will burn because to energize your body, there will be charge going to you and this electrical arc with a lot of temperature inside of it, so you will get burned even if you're not touching the ground. But if this distance is also not enough to isolate this area from these 3 kV per millimeters, because you are also energized with the line voltage when you get this charge. So if the distance does not create a sufficient minimum distance, the air in here will also be disrupted and you will discharge your energy to the ground. So the line will be discharging to you and you will be discharging to the ground. This is why we use ground sticks. Let's see the application. You have the wire here and you are far away from the line and you respect the minimum distance. This is the electric field and you respect this distance. So with this ground stick, as I said, is insulated from this side to this side, so this part is also insulated better than the air. So you touch the line with this surface and there is a wire that will be connected to the ground before you connect here, and you will discharge all the remaining voltage to the ground. So this will be the current, discharge current to the ground, and the voltage will reduce until it reaches 0 volts. So practically the line will take so long to reach 0 volts, and sometimes you need to work quickly, so you keep the ground wire there and you work so the voltage will be discharging, and you count sometimes so the voltage will discharge, let's suppose, to 1 kV. So in this voltage you can use gloves to touch the line and work safely even when the line is discharging to the ground. So this will avoid long outage of the line. So another type of ground stick, this is not a stick but you can also call this ground because this is applied in low voltage. As you can see, you will be touching these parts. This is like a plier, so you can see that the distance from here to here is minimum, so that's why this is applied in low voltage, because we saw that in low voltage the electric field is not bigger, so you can approach the cable and connect this plier and also connect this end to the ground. So you have here 3 sticks and here you have 4. Here you have 3 because in medium voltage lines you will not see the neutral cable. So there is only three cables, the phase A, B, C, and this is the ground stick that you will connect to the ground. But in low voltage you can see many times the neutral in the line or in the equipment. So we will have four different ground pliers. So the other one in blue is for the neutral, because in some installations the neutral has some potential in related to ground. So if you touch the neutral you can get electrocuted. So that's why you also discharge the neutral for your own safety. So this is used in motors, transformers of low voltage. So you can see here he's working in a low voltage line or a distribution line with a voltage of less than 11 kV. So you can see that the technician places this part in the line and in the other wires, so he grounded. So let's see an example of how we use this ground in motors. Let's suppose you have to work in this motor here and the motor is running. That means the voltage from this power supply with fuses going through this contactor. The contactor is now closed, meaning this line is in contact with this one is in contact with this one, and this one with this. So the motor is in voltage and it is running. So in order to work in the terminals you need to cut the voltage. So you send an order to the control circuit and you open this contactor. So in this case you will have no voltage here, here and here, but you will have voltage here. I will say this is voltage 1. So here you will have 0 volts. So now you can work in the terminals and you start working, and you are also in the floor and the floor is ground. You are working here in this phase. For some reason someone closes this contactor or the control circuit fails and this contactor closes. This voltage will be applied here, so you will have a voltage difference from 0. So the motor will start running and you are touching in this phase, so that means a voltage will be applied to your body or hand. And in this case, because you are in the ground and the ground has 0 volts, and here you have a voltage different from 0, let's say 220 volts, a current will flow from these 220 volts through your body to the ground. So you will get electrocuted in this situation. So how to prevent this electrocution with the ground protective equipments? So if you place the ground protective equipments in these 3 phases, and the ground protective equipment is with a shunt or common point and another end you connect to the ground. In this situation, when this contactor fails and closes, the voltage will be applied here in this line, but the current will not flow to the motor or to you, because the motor has a resistance different from 0 and you also have a big resistance different from 0. So the current will prefer to flow directly to ground in the easiest path without resistance, because resistance creates opposition to the passage of electrons. So the current will come here and go to the ground instead of going to here, here and here, and also to your body. So the current will not go to here, the current will divert to the ground. So this is why we use ground protective equipment when we are working for our safety. So there is another safety protections that we will see in personal protective equipment. So let's see another case. So in another case we have a 3-phase motor. You can see 3 windings here, but this is connected to a single phase supply voltage. To run this motor in a single phase voltage, you need to connect a capacitor like this. So the motor will run in this situation because this capacitor will charge and discharge in the motor when the voltage is zero, and you will understand it better in the next chapters. So when you want to work in these terminals of the motor and you open the power supply in these terminals, you get 0 volts. You cannot start working here directly because this capacitor is still charged. The capacitor stores energy. If you touch in this terminal, this one or this one, you will get electrocuted because this capacitor is charged and the voltage is approximately to the voltage applied. If the voltage applied was 220 volts, there will be 220 volts, but in a certain amount of time, because the voltage will be decreasing due to the circulating currents from the capacitor to this winding, capacitor to these windings, and by the way. So this voltage in time will be decreasing, but if you touch immediately after you open this voltage in the terminals, you will get electrocuted. So how we discharge this capacitor? This is why we use ground protective equipments. If you connect the ground protective equipment in this terminal and connect the ground protective equipment to the ground, a current will flow. If this is the positive, will flow from here to the ground, here to the ground, or creating a short circuit in this capacitor, so this capacitor will discharge quickly. So after that you can operate in the terminals safely. So continuing, we have the electric drill, and this is used in making holes on metal sheets and concrete walls. So the first electric drill is the corded drill. The corded is the drill in which you need power supply to feed the motor inside the drill. So this drill has a lot of power because you are using the power supply in the walls or sockets. And the next drill is the cordless with battery drill. So you can see the battery here, and this drill has not a lot of power comparing to this one because the main source of power is the battery, and as we know, still today in the present, the batteries are not strong enough to hold the charge. So for this tool to be efficient, this tool must have smaller values of watts comparing to this one, so the battery will remain for long periods of time. So in case you need to drill surfaces that does not require a lot of force, you can use this drill, but if you need a lot of power, you need to use the corded drill. So another type of drill is the pneumatic air drill, and this drill has a lot of power because you use compressed air in this hole here. So this has much more power comparing to the electric corded drill than comparing to this battery cordless drill. So when you need much more power, you use the pneumatic drill, and the performance also of this drill is huge. So the last type of drill most commonly used is the reversible drill, and this is a versatile drill because it supports the reverse of direction of this rotating shaft. So you can rotate the shaft in both directions, so this will allow you to tighten or untighten screws or bolts depending on the case. And sometimes you can find also cordless drills with reverse directions, but in most of the cases you will need a specific reversible drill for tightening and untightening bolts. So another basic tool is the hacksaw and electric cable cutter, and this is used to cut metal conduit and armored cables An armored cable is a cable with protection, is the type of cables you use in ground installations. So this armored is referred to a specific metal that will protect the installation of the cable. So because when the cable is in the streets, you cannot control all the cables in the ground installation. So let's suppose someone is working and he decides to open some hole in his ground in front of his house. So with the tool he cuts the cable. So if the cable is not armored, he will get electrocuted and will damage the cable. But when the cable is armored, the tool he is using to open the hole will not damage the cable. So this is a manual hacksaw, and you touch in this surface and you use this blade to cut the cable. And we have also an electric cable cutter, and this is powered by batteries or sockets, but this one shown here is a cordless. And let's see the difference between these two and the time needed to cut cables with these two. So you can see here the electric cable cutter, and this is the manual. So with the electric cable we already cut one cable, and this is the second. So we cut the second cable, and now we are cutting the third cable, but with manual we are still cutting the same cable. So you can see we cut 3 cables in 32 seconds, but with the manual we cut only 1 cable in 34 seconds, and this is a lot of time to only cut 1 second, because in electrical installations we need to be efficiently. We cannot leave the client without power or circuits without power, so cutting with manual hacksaw is not efficiently comparing to the electric cable cutter. So another basic tool is the hammers, and it is used in driving or pounding and also pulling out nails. So the first hammer is the claw hammer. This is the most common you will see in the market. It is normally curved in these surfaces and incorporates a V cutout to remove nails from the timber. And the next is the ball peen hammer, and the difference between this one and this one is that instead of this V to cut out nails, you have this ball peen, and this hammer is most used to shape metal parts. And the next one is the mallet or rubber head, and it is useful for striking materials such as chrome, wing outs, where a steel face would cause damage. So in cases where using these hammers will damage the material, you use these rubbers because the applied force will be less severe comparing to these two, because this rubber will create some force like a spring, so this will damp the total force you apply. So these are all the basic tools that you will need in industries or residence to work as electrician and to be succeed.